Now in this lecture, I'm going to introduce the Laplace transform. Now you may think that we will not get any question from the Laplace transform from the signal systems, right? But this Laplace transform is very helpful when we do problems in control systems, in network theory, and etc. Right? So that's why we need to study this Laplace transform. So even in the GATE exam, so we may get some questions which involve this Laplace transform, right? So it's very important concept. So we need to learn that one, right? So before we start the Laplace transform, so we have to know some basics. So why we need to study, or what is this Laplace transform is doing apart from the continuous time Fourier transform or etc. Right? Now, if you compare with the continuous time Fourier transform, so continuous time Fourier transform provides a representation for signals as linear combination of complex exponential of the form. See, we have seen the Fourier transform equation like this, right? X of j omega is equal to minus infinity to infinity x of t into e power minus j omega t dt, right? So this is looking like a linear combination of complex exponential. Now here, this term, this is the main important one. Depending on this only, we'll get different transform. So when this is s, so if s is equal to j omega, so that is, this s is purely imaginary, then we'll get the Fourier transform, right? Now if we generalize this continuous time Fourier transform, so this generalization of CT of t, that is continuous time Fourier transform, also called Laplace transform, where this s is equal to sigma plus j omega. So now we are taking, it's a complex variable. In the Fourier transform, this s is equal to j omega, purely imaginary we have taken, but this time we will take the complex variable. Now what is the advantage of this? We are taking the complex variable is the continuous time Fourier transform applied only for stable systems, right? Just remember, I will discuss this one. So this was only for applied for the stable systems, and this Laplace transform, the jet transform. This jet transform will start the after this Laplace transform can be applied to unstable systems also, and we can investigate any system, is it stable or unstable, causal or non-causal, right? Or this using this Laplace transform, jet transform, right? Now you should have some concept of this, what is the stable, unstable, causal, non-causal. If you recall, we discussed the LTI system, that is when we discussed convolution, there I discussed about once we know the impulse response of ht, that is if h of t is equal to 0 for t less than 0, so the system is causal, that is linear time invariant system is causal. Reason is it should not anticipate the future values, right? It should be non-anticipating. So that is a causal system, right? So how can we say h of t is equal to 0 for t less than 0? Mean only for causal systems only we will get like this, right? If h of t is not equal to 0 for t less than 0, so it's a non-causal system. Similarly, if we integrate this h of t from minus infinity to infinity, if we get a finite value, we can say the system is stable, right? Because when we apply bounded input, we are getting the bounded output. That is the meaning. So causal and stable system should be generally the practical circuits or systems which are doing the functions, right? So it should be stable and it should be causal also. Now, how can we relate this system causal and stable into the continuous time Fourier transform? If you see continuous time Fourier transform, x of t is equal to, we have taken e4 minus at u of t, where a mod a less than 1. Then only we can apply the Fourier transform of these signals. Otherwise we cannot, because when a is greater than 1, suppose if a mod a is greater than 1, suppose, so the Fourier transform will become unbounded. Actually it will not converge, because e power minus at into e power minus j omega t, then it will become e power minus of t a plus j omega. Now, if a and this plus j omega, it should be greater than 0 to converge. See, this is u of t, right? It should be 0, right? Now, when I substitute infinity, it should be e for minus infinity. Then only it will be converges. Otherwise, it will diverges. So that's why we should take the a less than 1. So to make, so it's a bounded signal. So right here. But in Laplace transform, there is no constraint about this a, right? A can be less than 1, greater than 1, etc, etc. So it can be e power a t u of t, e power minus a t u of minus t, etc. Any signal we can find the Laplace transform, right? That's why we say for unstable systems also we can apply this, or we can say for unbounded signals also we can apply the Laplace transform, right? Because so that will clearly visible. So e power a t u of t is like this. When we multiply with some decaying function like this, so this will be converges, right? So how we have to see. I think what is the some importance of this Laplace transform. The main thing is the generalization of Ct of t is known as Laplace transform, and the Laplace transform can be applied to unstable systems, and to investigate if the system is stable or unstable, right, causal or non-causal, that also done in Laplace transform, right? Now we'll discuss what is the formulas for the Laplace transform. So to find the Laplace transform for any signals, if you recall again when we discussed Fourier series representations, in the last topic I discussed when we apply a complex exponential signal e power st or exponential signal, so what we will get, so this is the input, so output also in the form of e power st but with an eigen value. This is e power st is called eigen function, and this is called eigen value, right? There we discussed this h of s is equal to minus infinity to infinity minus infinity to infinity h of t into e power minus st dt, right? So this is generally I said it's a Laplace transform, right? So now we can find easily what is the h of t to make inverse Laplace transform, right? But here what is s here? Now it's a purely complex number, not purely imaginary. It is complex number, complex variable. So s is equal to sigma plus j omega. Now what is h of t? H of t is impulse response, right? Now if we generalize this one for x of t, for any x of t, so I'll take generalized signal some x of t. So what is the Laplace transform this x of t? Generally we denote like this. Laplace transform x of t is equal to x of s is equal to minus infinity to infinity x of t into e power minus st dt, right? So this is the Laplace transform equation. Now how to find the given signal Laplace transform? Now we have to relate this one with the Fourier transform, right? Now if I substitute s is equal to j omega first, so what is it will become x of j omega is equal to minus infinity to infinity x of t into e power minus j omega t dt, right? So anyway, this is we know that is it is nothing but Fourier transform of x of t, right? So this is x of j omega. Suppose assume as 1 equation 1. So I'm just substituting s is equal to j omega in this expression. So it is becoming like this: x of j omega is equal to minus infinity to infinity x of t into e power minus j omega t dt. Now it can be replaced by like this Fourier transform. X of t is nothing but this. Now if we replace s is equal to sigma plus j omega, so what it will become? X of sigma plus j omega is equal to minus infinity to infinity x of t into e power minus of sigma plus j omega into t dt. Now to make this similar to the Fourier transform, what we'll do is minus infinity to infinity x of t into e power minus sigma t I'm taking out. So this is one term into e power minus j omega t dt. Now if you relate this expression with the Fourier transform, so I can say Fourier transform x of t into e power minus sigma t is nothing but the Laplace transform of x of t, that is x of sigma plus j omega, right? So that is the relationship between this Laplace transform and Fourier transform. That is, when sigma is equal to 0, Laplace transform x of t will become Fourier transform of x of t. Yes or no? Right? That is, sigma equal to 0 means e power 0 is 1. So it is Fourier transform x of t is nothing but Laplace transform of x of t. Right? So that is the relation between this Fourier transform and Laplace transform. Right? Now we will see one example to find the Laplace transform. Suppose signal is this. So generally we talk about the basic signals only, which is e power minus at u of t. Now what is the Fourier transform? X of s is equal to minus infinity to infinity x of t into e power minus st dt. Now u of t is from 0 to infinity, so the limits will be 0 to infinity. What is x of t? E power minus at into e power minus st dt, right? Now, so what it will become? E power minus, if I take t common, s plus a into dt, here 0 to infinity. And now again it's looking like e power x. So e power x means e power x only, and we need to differentiate in the denominator, that is it become minus of s plus a, right? This is 0 to infinity, this is x of x. Now we need to see that, so see, when we are substituting infinity, e power minus infinity will be 0, but inside there is a term which is s is equal to sigma plus j omega, so that we'll see like this: e power minus t into sigma plus j omega plus a by minus of sigma plus j omega plus a, right? And this is 0 to infinity. Now if I try to apply this t in place of t infinity, so it will become e power minus infinity, unless until this, anyway omega cannot be negative value, but sometimes this sigma plus a may be negative, so if negative into negative it will become positive, so it will, e power infinity will become infinity. That is, this integration will diverges when the sigma plus a is less than, it's less than 0. Yes or no? So that's why the condition comes now, that is, what are the values of this a value or sigma plus a, for that this integration or this term will be converges. So that is the main important parameter in the Laplace transform. Is generally it is called a region of convergence, right? So if you recall, when we talk about the continuous time Fourier transform, so here there was a condition, that is a less than 1, but here no condition is there, but to satisfy or to converge this integration, so there is other condition is coming, that is sigma plus a should be greater than 0, it should not be less than 0, right? So whenever it is less than 0, so minus will be positive, so e power infinity will come, which will be diverges, right? That is the region of convergence where this limits or the integration converges. That is, see, sigma generally we say, so we can say sigma plus a should be greater than 0, or sigma should be greater than minus a. Now what is sigma? So sigma s is equal to sigma plus j omega. Sigma is real value of s, this one is imaginary value of s, right? So generally in any textbook or whatever, we generally say sigma is real value. So real of s should be greater than minus a. This is the ROC, of this signal. So region of convergence. So real of s should be greater than minus a. Then only this limit or this uh, integration will converges. So whenever this is greater than minus a, then it will be converges. If I substitute e power infinity here, I will get 0 minus. So if I substitute e power 0, it will be 1, but it is having minus of sigma plus j omega, so I will simply write s plus a on this. So what is the Laplace transform of this signal? 1 by s plus a, and always we need to represent ROC. ROC is what? Real of s is greater than minus a, right? What is the meaning of this ROC where R real of s is greater than minus a or sigma is greater than minus a means? So we discussed that the Fourier transform is applicable to only some signals where the condition is a is less than 1, right? Similarly, but this Laplace transform is applicable to all the unstable signals also, unbounded signals also, but there is a condition that for some values of real values of s or some values of sigma, only it will be converges, not for all values. So that is the represented by this ROC. So right, only for some values of real of s which is greater than minus a, this will be applicable or it will be converges, right? That is the this ROC is telling here, right? Now suppose if a is equal to 0, right? If a is equal to 0, that is e power minus at into u of t will become what? Simply u of t, right? That is unit step sequence. So what is the x of s now? 1 by s where a is 0, and ROC will become real of s is greater than 0, right? So that is the Laplace transform of u of t, unit step signal. So compared to continuous time Fourier transform, it is different. When I substitute s is equal to j omega, it is become 1 by j omega plus something is there in continuous time Fourier transform, right? Here we will not get any extra term. Now, so now we got two signals Laplace transform, that is e for minus at u of t. Now what is the Laplace transform? 1 by s plus a and ROC. Don't forget to write ROC. We have to write always ROC, that is real of s should be greater than minus a. Now one more is u of t, which is the Laplace transform is 1 by s only, and ROC is real of s is greater than 0, right? Now we'll see one more example, that is the question 2. If x of t is equal to, similar to the previous one, if minus of e power minus at into u of minus t, right? So I'm taking the reversal of u of t, so u of minus t, here I'm putting some negative value, right? Minus. Now what is the Laplace transform? This type of signals we have to see. So x of s is equal to, I'm going first we'll discuss what is this u of minus t. See, u of t is like this, right? From 0 to infinity we'll get amplitude as 1, right? Now the reversal means u of minus t is from minus infinity to 0 will get, right? This is u of minus t. So that means the limits of this function will be minus infinity to 0. That is the meaning. So I'm writing directly the limits minus infinity to 0, and the function I'll use minus e power minus at into e power minus st dt. This is the Laplace transform we are finding. Now if I take minus common, and this will become e power minus t of s plus a, right? And differentiation minus of s plus a. Limits will be minus infinity to 0. When I substitute 0, there is no convergence problem. When I substitute minus infinity, see here, minus will be plus, so e power infinity will be infinity, so it will be diverges. Now what is the condition we need to make is, suppose in this, that is real of s. So right, if real of s is less than minus a, sorry, it should be less than minus a, that is sigma plus a if it is less than 0, right? So less than 0 means minus will be positive. Now if I substitute minus infinity, so it will become e power minus infinity, then it will be converges. So that will leads to sigma less than minus a, which is leads to real of s is less than minus a. So are you getting my point? See here, if you substitute here, so I'll write like this: minus e power minus t sigma plus j omega plus a, right? Now by minus of s sigma plus j omega plus a. Now to make this term converges, so what we need to do, the sigma plus a we need to make negative value, right? When this is negative value, then only it will be converges, right? So whenever it is negative, so what we will get? 0 means we'll get 0, I mean e power 0 means 1, right? By minus of sigma plus j omega plus a minus, if I already assumed that sigma plus a is less than 0, previously we assumed that it was greater than 0, now we have to assume less than 0. So when it is less than 0, so it will be minus of minus, you will get positive. So anyway, so you may think that, so this will become e power minus t into sigma plus a into e power minus t into j omega. Now you may think, so this is infinity, so yes or no, if I substitute minus infinity here, so it will become e power infinity, so which is infinity, but here this is sigma plus a is less than 0, so it will be e power minus infinity into minus value, right? Now this is minus and already minus is there, right? Minus infinity into minus, again we'll get minus here, so 3 minus will be e power minus infinity, so it will become 0. So 0 into anything will get 0 only, right? See, t should be minus infinity, so minus 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 positive into this, also we are assuming this is also negative term, so minus, so we'll get e power minus infinity, so it will be 0. So 0 into anything will be 0, so that's why it is converging, so it is 0. So what is the value? Will get minus minus plus 1 by replace sigma plus a by s, so it will be s plus a. And what is the ROC will get? ROC is real of s is less than minus a. If we compare this one and the previous one, the Laplace transform are same, but only the ROC is changing. So previously we got our real of s is greater than minus a, now we are getting real of s is less than minus a. That is the only difference, right? Now how to represent this ROC in a plane? So generally we take S plane. So S plane, which is having a real plane, real path on a real axis and the imaginary axis, right? So this is sigma and this is like j omega, right? Now, so always in the S plane will have only strips. So because real of s is greater than minus a, real of s is less than minus a, greater than minus a, 1, 2, etc. So it will contain some parallel strips. So if this is minus a strip, now for x1 of t, that is e power minus a t u of t, so the Fourier transform, I mean Laplace transform is 1 by s plus a, and the real of s is greater than minus a. So how to represent this one? So this one will be represented like this, right? So real of s is greater than minus a. So this is the parallel strip in the S plane, right? Like this. So this is the region of convergence. So only for these values it will be converges, for these values it will be diverges. That is the meaning. The second one is this is minus e power minus a t u of minus t. So the Laplace transform is same, but the real of s is less than minus a. Now what is the convergence? I mean the in S plane, how to represent? This is imaginary axis, this is real axis, and this is minus a. So less than means you will get in this part, right? This is the region of convergence for this signal, which is e power minus a t u of minus t. Now you know why we have substituted minus here. If there is no minus here, we will get minus of 1 by s plus a. If there is a minus, we will get 1 by s plus a. Why we have put that minus is to compare these two values, right? So this is about the Laplace transform. Now we have to only perform this equation to find the Laplace transform of different signals, right? I will do some more problems from this Laplace transform before we enter into another topic. That is, suppose if I take e for minus 3t u of t. Now we have to remember the basic signal Laplace transform. So we know that e for minus a t u of t, what is the Laplace transform? 1 by s plus a, and the region of convergence is real of s is greater than minus a. We compare this one. So what is the Laplace transform e for minus 3t u of t? The Laplace transform is 1 by s plus 3, and here real of s is greater than minus 3, right? Now suppose two signals are given, e for minus 3t u of t plus e for minus 2t u of t. Now what is the Laplace transform of this type of signals whenever there is a combination of two signals? We know that from the linearity concept it can be possible. From the output also should be summation of these two. Now we know that e for minus 3t u of t, what is the Laplace transform? 1 by s plus 3, but region of convergence is minus 3 greater than, sorry, this is minus 3. Similarly, what is e for minus 2t u of t? The Laplace transform is 1 by s plus 2. Here real of s is greater than minus 2. Now the ROC, if we draw in the s plane, that is a real and imaginary, one is minus 2 and one is minus 3, right? Now one is minus 2 means, so it will be like this. So whenever there is a two signals are we are adding, so we need to take some common ROC for which these two will be convergent. The next two ROC is greater than minus 3, so it will be like this, right? Now what is the common ROC here is, see here, so from minus 3 to minus 2 only this value is there for minus 3, but whenever greater than minus 2, minus 2 as well as minus 3 are meeting, right? So what is the common ROC here? This common ROC is real of s is greater than minus 2. That means these two, e for 1 by s plus 3 plus, so I will type like this, x of s is equal to 1 by s plus 3 plus 1 by s plus 2. So these two terms will be converges when the real of s is greater than minus 2. So that is the this ROC. Whenever there is two signals are, we are taking sum of the two signals, there should be some common ROC for both signals exist, the converges, right? Now so if I take LCM, so this will become s plus 3 into s plus 2, and this will become s plus 2 plus s plus 3. So 2s plus 5 by this s square plus 2s plus 3s, 5s plus 6. So this is the overall Laplace transform where the common ROC is real of s greater than minus 2. This is how we need to take the summation of the two signals, right? Next we will see, we said the Laplace transform is applicable to unbounded signals also. So if I take this x of t is equal to e power at, which is unbounded, so we'll see is it converges or diverges. Now what is the Laplace transform? X of s is equal to, so u of t means from 0 to infinity, the function is e power at into e power minus s to dt. Now so if I take t common, so it will become minus s plus a. So that is, so what we do is, see, we need to here infinity, so we take e power minus common the t, so minus common means it will become s minus a, right? So integration like this dt. Now what is the e power x integration? E power x minus t into s minus a by minus of s minus a. Now you think just stop the video, just find it, what is the values of a which will this term will be converges, right? Now how to find that one? So if I substitute infinity here, so it should become e power minus infinity, but see here there is s minus a, right? So suppose if this s minus a is negative, right? If this is negative, so negative will be positive, so it will become e power infinity. Yes or no? So to make this term converges for some values, so we have to take the ROC of this one. So if you are confusion, so what you will do is replace this as sigma plus j omega minus a. So what is the sigma a should be? Here it is e power minus t. This one should be positive, that is the meaning, right? Whenever this is positive, this will become negative, so e power minus infinity will become 0. So sigma minus a should become greater than 0, then only this term will be convergence. So what is the convergence? ROC is real of s should be greater than a. So e power infinity, see, this term is positive, means very good. So e power minus infinity will come, it will be 0. So 0 minus, if I substitute over 0, it will be 1, but minus of s minus a. So what is the overall Laplace transform? And 1 by s minus a, where the convergence or ROC is real of s is greater than a, right? So that's why I told the unbounded signals also we can find the Laplace transform, but this transform exists for only some values of a, right? That is, or some values of the real part, which is real of s is greater than a. See, not for values of a, the ROC, the sigma, the real value of s, for some values of real of s, it will only converge. Those values are real of s is greater than a. And here 1 by s minus a. You have to remember e for at u of t means what is the Fourier transform? Laplace transform 1 by s minus a, and the real of s is greater than a, right? Now you may think, if this is for you, the assignment, suppose minus of e power at u of minus t. So what can be the Laplace transform, right? Just compare, just you will get same 1 by s minus a, and it will become real of s is less than a. You do it on your own and find is it right or wrong. Just intimate me, right? Post a comment. So this is our some introduction to the Laplace transform.